All right, good morning. This is e-learning day for April 2nd for Honors Math 3. All right, so we're going to finish up the week with finding the sum of a geometric sequence. All right, so there are two types of geometric sequences here. There's the finite geometric sequence and the infinite. So we're going to use this particular formula for the finite geometric sequence, or the sum of a finite geometric sequence, right? If we have a defined number of terms that we want to add up, if there is an infinite number of terms from the geometric sequence that we want to add up, this is the formula. Okay, so let's go back to this one. Again, to find the sum of a finite geometric sequence, you're going to take the first term and you're going to multiply it by this ratio, which is made up of 1 minus the common ratio put to the nth power, divided by 1 minus the common ratio. For the finite geometric sequence, or the sum of, you're going to take the first term and divide it by 1 minus the common ratio. Now, this formula only works, it says converges, meaning it's going to get an answer or a summation only if the common ratio is a value between -1 and 1. Okay, so we're going to go through a couple examples here from the note sheet. All right, so let's do one first for the finite geometric sequence. And we know it's finite because we're only adding up to from the first to the 8th terms. Okay, so here, again, we are looking for the first term. So again, this is the common ratio. Right, so we have an R value of 1/2. Right, what we don't see here is our first term, which again is normally written to the left of this expression. So since we don't see a number there, we're going to assume it to be 1. Okay, so the first term is 1. All right, so that's all we need to be able to find this sum. So we want to find the sum of the first 8 terms of the geometric sequence. Plugging it into that formula that I showed you initially, we're going to take the first term, which is 1, and we're going to multiply it by this ratio, which is made up of 1 minus the common ratio put to the nth power. Again, n is 8, all over 1 minus the common ratio. Okay, so we're going to plug that into our calculator. All right, so let's do parentheses. 1 minus the common ratio of 0.5 put to the 8th power. Divided by 1 minus the common ratio. So we get that number, and we multiply it by 1. And there we have it. So there's our sum. So the sum of our first 8 sequences. Let's see if we can put this into a fraction. Let's see. Yes, all right. So again, we want the fraction form because the common ratio was given in the form of a fraction. So here it's going to be 255 over 128. So there's our sum. Okay, so let's do one more of these of this type. All right, so here, this one, we can clearly see what the first term is. The first term of this geometric is 2.5. The common ratio is -2. Okay, so now we got to remember that, right, so for a finite sequence, there is no restriction in terms of what the value of r needs to be. And we only have that restriction here for the infinite geometric sequence. Right, so there is no restriction. So again, our r value of -2 is valid. So again, to find the sum of the first 10 terms of this geometric, plug it into the formula. The first term times 1 minus the common ratio. So that's a -2. So we're subtracting a -2 put to the 10th power all over 1 minus the common ratio. All right, so again, we plug that into our calculator. 1 minus to the 10th power divided by 1 minus a -2. So we get that, and then we got to multiply it by the 2.5. Right, so here the sum of our first 10 terms. Now this one we can leave in the form of a decimal because we have values in here that are decimals. So there's our sum. Okay. All right, so let's move on to the infinite geometric sequences. All right, so again, we're going to be using the second formula here for an infinite geometric sequence. Okay, again, we need to watch out. We need our r value to be between -1 and 1. All right, so we're looking at this first summation. All right, so our first term is 5.7. Our common ratio is 0.6. And 0.6 is definitely between -1 and 1. So this one, we're going to be able to find a sum. So let's go ahead and plug that into the formula for the sum of this infinite, right, geometric sequence. This is a nice, easy one formula to use because we just take the first term and divide it by 1 minus the common ratio. All right, that's for an infinite sequence. So it's 5.7 divided by 1 minus 0.6. 14.25 is our sum. All right. All right, so that's it for today. So if you guys have any questions, let me know. All right, you guys have a great day and a good weekend.